This is the final part of the JCON 2025 interviews with a lot of tips and tricks.
Welcome to the Foojay Podcast, all your news about OpenJDK.
In the 3 previous podcasts, I served you interviews from the JCON conference about being a better Java developer, evolutions in Java, and how to use AI with Java. But I talked to a lot more people during the conference, so this podcast focuses on tips and tricks. Let's learn from the many other experienced visitors of JCON. Let's start with keeping your code up to date and how you can automate code changes. Merlin Bögershausen from Moderne shares how we can use OpenRewrite to modernize code, optimize the number of libraries in your project, and find unused code with Azul Intelligence Cloud.
OpenRewrite can be used to streamline your tech stack, to achieve some consolidation of the tech stack in terms of if you have a big organization. From time to time, in the past, it was a good choice to go with Apache Commons logging. Then it was a good choice to go with SLF4j and with Log4j, and all of them were valid choices at their time. Some of the projects are not just maintained on a minimal level, and some of them have different version in use. So we have a wide variety of libraries used for logging at all inside one organization, but an organization should stay on a common code style of coding that includes library and API usage. And with OpenRewrite, we can migrate from one library to another library, or in terms of SLF4j, from SLF4j to SLF4j, to streamline the versions, to streamline the API usage, and to achieve a more standardized use of the API.
I've seen this before in older projects, legacy projects, that suddenly seem to have 3 different XML libraries. So this is a bit the same idea. If you only need one, that's a better approach.
Yes. And what we also see in big organizations is that even if they have central management of dependencies in terms of versions, and as a big parent or something like this, or a bill of material, there are still different versions, for example, JSON in use. But if you're connecting 2 services with a completely different version of JSON in between, that could be a problem in the future, or could be right now. And if you're using a recipe to migrate all of them to the same version, to the most recent, without CVEs, without problems of end-of-life cycles and something like this, so then you have, a more standardized way. And when you have this standardized way and the standardized use of APIs, you can move even faster towards different cloud provider, towards a different implementation and different application service to overcome these vendor lock-ins, to achieve more digital sovereignty, and get rid of a special provider that you know.
Yeah, that's the great thing about Java. You have this great community creating libraries, but CVs, you mentioned them briefly. So an older version can also have security issues. Is that something you can alert, detect?
That's definitely something we can alert. So with OpenRewrite, there is a recipe. It's called find and fix vulnerability dependency with vulnerabilities, and it is using the GitHub Code Advisor Security Advisor database, and to move migrations, to detect migrations with CVEs and migrate to a fixing version. And this recipe can be applied from time to time. And whenever this recipe finds something, there could be an alert, or there could be an automatic fix for this. With the feature called data table, every recipe can be used to collect data or to transform code. The collecting data feature can be used to build dashboards on top of that. So we do this with our modern SaaS, with the software as a service solution. There's some, you can develop their dashboards and characterize your current data you have available for CVEs, for unpatched versions, for end-of-life versions approaching. So all of them is.
There was also the announcement that you will cooperate with Azul to find dead codes. How does that work?
Azul has this very neat feature that they can analyze your code in production in runtime and identify methods or code passages that are never used in the last weeks, months, years, or something like this. And with this data, you can go to your code and remove that code. You can do that by hand, or you can use the modern tooling. We have a recipe for this. This is working together with the Azul Cloud solution, which is pulling the data, which method, which code passage is no longer in use, and then removes this code, opens a PR, so the team don't have to do it manually. They just have to accept. That's the same for, this is combined with removing unused imports, removing unused dependencies, because if the branch is deleted, probably a dependency is no longer needed. All of this comes together with this recipe, with this data coming from Azul, and is being serialized, made reality with OpenRewrite and Modern.
So removing that code helps you to have less work as a developer, less code to maintain, because some people don't realize that unit tests need to be kept in sync with code, which is probably sometimes never used.
Yes, because unused code within one project, we can easily determine unused code by following the code path. The problem is if you have a public method, then it is a used call, and everything what is following this public method is considered used call. With the data from Azul, we can determine, no, it isn't used in the last 5 years or something. It's safe to delete. And then we see, okay, it's also safe to delete to this private classes here because it's no longer used. It's also okay to delete these unused test cases here. It's also okay to remove the dependencies at whole. And so they're just one method that is flagged as this method is no longer used can end up in a full module being removed because it's no longer used. And that's the beauty. Deleting code is always a good thing.
Eberhard Wolff had a talk at JCON about measuring developer productivity. I asked him if tracking the number of fixed tickets is a good indicator to measure this.
The number of tickets solved might even be a good idea. The question is, what do you do with that data? So if you try to identify obstacles and remove them, then I think that might be a good idea. But if you try to incentivize people using that metric, it might be a bad idea. And there is even a law called Gotthard's Law. And Gotthard's Law basically says if you manage by some metric, then it ceases to be a good metric. So if you manage by test coverage, for example, people will start to test trivial code, and then test coverage doesn't really tell you whether the tests are good or bad. It just becomes pointless, and therefore you have to be careful about these kinds of things.
Yeah, so if I know that my test coverage should be 100%, I'm just aiming at the test coverage.
Exactly, and then you're basically gaming the system. And that is why I think it's important to figure out what the goal is. And I'm also talking about the space framework, which gives you some ideas about which topics you want to measure or which metrics you want to measure. And the idea is to basically ask the question, okay, so what is it that you want to care about? What is the problem that you want to get a better understanding about? And then you choose some metrics and figure that out. And I think one of the interesting points is that it's also about developer well-being and how they feel, because and I think that is something that is often overlooked in the industry. If developers or teams don't feel bad about what they are doing, chances are that what they are doing is actually not the best, the most productive way. But that is something that people hardly care about, in my opinion. It's something that is, well, that mostly people don't think about too much.
So well-being, Jira tickets, are there other specific things that we can measure that will reveal how productive our team is?
So there are obviously quite a few things. And I think one of the things that I find interesting and that quite a few people don't really know are the DORA metrics. And it's about how often you actually deploy. And when I've asked people whether this leads to more productivity to deploy more often, it's actually something that they have a hard time figuring out. And if I ask them, well, what's the benefit of deploying more often? Usually they don't come up with any kind of productivity things. But in fact, if you deploy more often, more frequently, then you will identify the bottlenecks in your process. You will optimize them away, and therefore the process becomes better. So it's more like a lean optimization thing, right? Like in lean production, where you try to have a constant flow of things through your, whatever it is, factory. So if you try to get a constant flow of things through your pipeline, through your process, then chances are that you get more productive. And I think this is so very important because it's one thing that we can talk to managers about. So here is something that improves your productivity. It's actually easy to measure and just do it. And the other thing is, so that is something that I even might ask you. So what do you think? If you deploy more often, what's the result on burnout? So will it reduce burnout? What do you think?
I think in the beginning, it's a disaster with a lot of troubles and getting things fixed. But if you come into some kind of flow, I think it can reduce a lot.
Yeah, and that's also something that a lot of people don't really get right. And there is data about that. So there are the studies, the DORA studies about that, and they actually say that it reduces burnout. But again, so you have the sort of the exception. So if I ask people whether it reduces burnout, they are not too sure. But it turns out that most of the people actually want to work in an environment where you deploy more often, which is interesting, right? Because if they think that this is the better environment, why isn't it so obvious that it would also reduce burnout? And again, that is something that we have to talk about, I think, more, that the environment that developers like to work in is probably more productive. And it's also something that I'm guilty of, because like 10 plus years ago, I wrote a book about continuous delivery. And the reason why I did that is because I felt that this is a better way. It would make me feel better to have a constant flow and to be able to deploy systems just like that. But in the book, it doesn't really say that. So I talked about, time to market, but I didn't talk about that. So that is one of the lessons learned, in my opinion, from writing that book and from talking about these things.
Being a productive developer is heavily influenced by the quality of the code you have to work with. Annelore Egger had a talk about dealing with bad code and how it's not your fault. She explains why.
Was about business complexity that can also translate into bad code quality. If you make the business logic too complex, then it will also translate into the code. And if it's more complex, the code quality starts to decrease.
If it's not your fault, if you're part of a big team, then how can you fix it or try to fix it or improve it?
Yeah, so in general, I also talked a lot about the fact that it's important to even realize that you have this issue, and a lot especially when it's complexity that came from the business and translated into bad code. It's very important that you try to improve the communication with the business. And one thing I mentioned is that I think a lot of people have assumptions. So the business team had some assumptions about how technical things work, and developers have sometimes some assumptions about how the business works. And these assumptions are often not correct. So if you build it on that, then you build something that is not good. Mm-hmm. So I think it's very important to realize when you make assumptions about something, and then just make sure to try and ask more questions to be sure to really understand the other side, but also to try to give as much information as possible so the other side can try to understand it, so you can overcome this gap.
People who start doing development because they think, I just want to work with the computer and not with people, they're probably wrong. Communication is just as important as the development itself.
Yes, I agree. First of all, you also have never a project where only one person programs. So even if you don't look at the communication between developers and business, it's also important that different developers have a good communication. I also touched on that a little bit, that there are often misunderstandings when someone, for example, doesn't use like the correct terms, and then you don't speak of the same thing. So yeah, you're right. It's not only working with computers, communication and in general working with our people, I think, is very important as well, and maybe sometimes even more important.
Michael Vitz had a lightning talk about unexpected things you can do with Java. What is it exactly he wants to explain with his talk?
Main idea was there was a lightning talk by Gary Bernard, I think, on a Rails conference where he did a JavaScript talk and showed what's possible with JavaScript. And there are some crazy stuff like subtracting numbers from strings, and you get effects you won't believe. And I thought we usually make fun of other languages and forget that our language may have some rough edges which looks the same to other communities. And so maybe we should a little bit laugh about ourselves. And so that's the main idea. It's not about that deep learning.
Did anything related to this subject change with newer versions? Do you see changes in your examples because Java evolves itself?
One new example is related to the switch expression instance of things with integers and primitives. So there's a nice effect you can show, which was not possible because before it was built in. And I mean that manipulating stuff from strings, it was easier in previous JDK versions. Nowadays, you have to set a flag to make it possible, or which is not included within the talk, but there is an example what's faster, to uppercase or to lowercase, and that depends on your locale, because, for example, for the Turkish language, there are some special rules which are included in a not a hash map, the synchronized one below, and this is nowadays very much faster than on JDK 8 or 11, for example. So yeah, they change a little bit.
Yeah, it's unbelievable what's under the hood. I've written a blog post about the time zones. That, for instance, changing to a newer version can give you a different currency for some country. So there is indeed a lot which is changing within the runtime and the library that we don't expect to see.
Yeah. I remember your case. I think they changed the lookup of.
It was Croatia, the currency, and for Kazakhstan the time zone.
Yeah. And I mean, if you update from one JDK to another, that are mainly the points you miss when reading through the documentation, right?
Yeah. But the nice thing that you share is that some things become a lot faster by just changing the runtime. Isn't that unbelievable that you don't need to change your code and still can benefit from other improvements?
Yeah, I mean, that's one of the magic points of the JVM, right? I mean, if you use, for example, JRuby is so much faster than the original Ruby runtime. And who would have thought that a higher level language could be faster than the lower level languages, which are directly at the machine, right? So, I mean, the whole JVM is basically, it's fascinating in case of speed and performance and such things, yes.
Michael Simons is staff engineer at Neo4j, so he is the perfect person to explain us what is the difference between a graph and a relational database.
When you think about relational databases, the columns and the rows of a table, they make up relations. Many people mistake relational databases, the constraints you do, foreign keys between relations as actual relations. Those are not the relations. In Neo4j, we store physical relations between entities, such as like a movie and the actors of a movie. And you can query those relationships directly. We have a query language for that is called Cypher. And in the last year, there has been a new standard, which is GQL, Graph Query Language, not to confuse with GraphQL. That's a different thing. Yes, that's the main difference between a relational column or table-oriented database and the graph database, right?
And is this hard to learn if you're an SQL experienced developer?
Depends on your mindset, I have to say. So I said I'm responsible for Spring Data Neo4j, which is an object graph mapper. And it's very similar to object relational mappers. Some people only interact with the database through these mappers. So you have two parts, object and source mapping and query generation. If you ever think about only coming from that angle, it's generally hard to leave Java for a moment behind and go to a query language. I don't think that SQL is hard, and I don't think that Cypher is hard. It's a way, I wanted to avoid saying AI, but it's like a good prompt. You tell the thing what you want, and it comes up with the optimal algorithm to pick data from a store and massage it in the way you want to project it in the end.
Yeah. Do you agree that as a database developer, you should know SQL and not only rely on mapping things and libraries helping you? Can you be a better database user if you know the language of the database itself?
Absolutely. So you're completely running into open doors with that statement with me. So I've given talks about Neo4j, OGM, and Spring Data, and I also given talks about SQL and other tools. And I think you have to know the lingua franca, the language of your database, to fully utilize it. That's for sure, right? These mapping tools, they are general purpose tool, and you can only generate queries not on the surface, but general purpose queries. But you pick a specific database for a reason. You pick a graph database. Maybe you want to detect circles or fraud rings. You want to use it for graph rec in AI. You picked it for a specific reason, and for that you have to know the language. Mappers can only help you so far to hydrate object graph afterwards for you. And in relational databases, you often have the point that you have to understand the transaction machinery to know how the second level cache behaves or doesn't behave. So yes, I think you should absolutely know the groundworks for these mappers.
One of the arguments for a mapper is, but maybe we will switch to another database later. Does that happen a lot?
I haven't seen it in 25 years of software engineering, really not. Maybe if you have a product that you ship dedicated for different databases, like you allow the user to either pick MySQL or Postgres or whatever, then maybe that's a good reasoning for doing so, right? But in big enterprise projects, I haven't seen it in my career once.
So the point is you really should think about which database you're using when you're setting up a new project. Each database has its proper use.
Yes, absolutely. And there's maybe voices that say use an abstraction like Spring Data, like the repository abstraction, which I think is a great abstraction to think and to integrate your database interaction with something like domain-driven design, that's for sure. But I would not sell it as an abstraction over like MongoDB, Redis, Neo4j, or relational databases. They will definitely behave completely different and do different things for you, and you should not abstract this away.
Stefan Böhringer developed a web application to train and measure reading skills in schools in Germany. As a Python developer, he deliberately chose Java as it allowed him to develop this application very fast.
Java is our main driver. We use the Quarkus framework. This is our main engine, which drives all the application, the whole business logic, the connection to the databases, the connection to it's running in Kubernetes. We have different keycloaks, also running a keycloak, a official identity management system of the German government. We connect to this. So this is all done with Quarkus. And then on top of that, there's a Next.js React application, which does all the front end, but all the data handling is with Quarkus.
So this sounds like it's a big thing. How many students are there in this system?
Yes. By now, we had our first measurement time slot in October 2024 to November 2024, and we tested 180,000 students in the first time slot. So there were about 1,400 schools from the 2,200 schools in the state of Bavaria in Germany. So we had a 65% of all the schools. And it was a big issue because we're generating data which helps us in the research, and is an unseen size, unseen amount of data we got from the schools in Germany. So this is really a unique data set.
Do you think you could achieve same results with other languages, or did you choose Java as we know it already and we know this is reliable for what we want to achieve?
Yeah, we didn't use Java at the time we got the project. We are most familiar with statistical programming, like programming in the R programming language. We use Python a lot for some projects before, also application development with Python frameworks, but we better know the Python data science and machine learning stack in our department. So it was a big issue for us. Which technology stack should we use? And because a friend of mine who developed Java for 20 years now, he introduced me to a Java user group in my area, and I went there. And Adam Bean was there. I think you know Adam Bean, and he displayed Java as a very good opportunity. And I went home and I did, 3 weeks of researching, reading about Quarkus, Hibernate, JakartaEE, and so on. And I did dummy projects, prototype things, and I came to the conclusion that we should use Java because it's such a reliable thing. And that was the start. So we came totally fresh to this Java world, and it was a really easy introduction.
Which is nice to hear, because for a lot of people, Java is old, is too difficult to learn. But I hear you start with Quarkus, with actually the latest of what is available and what has started within the Java community. So isn't this great that you can so quickly catch up with the new technology?
Yeah, of course. I was totally surprised. I mean, really, when back in 2003 and 2004, when I was a student at the university, I had to learn Java, and it was this curriculum, and it felt really clunky, and I don't know. But 20 years later, it evolved in such a way that it was a really nice experience to program with Java, aside from Quarkus. Because with all I'm a data guy, I think, so it was really natural for me to use the Stream API of Java and so on, and also the records and optionals and so on, doing things with Hibernate, with the database. Of course, it could be that I have 20 years of developer experience, so I tried a few languages and a few frameworks, okay, but it's totally surprised me that Java really felt nice and easy, and I really loved to program in Java. So it's I think now, 1.5 years after this, it's my second language I program in, besides Python, of course, because,
Johannes Rabauer helped Stefan with his project and also had a talk at JCON about things he learned from earlier projects. What is the stuff he wants to share?
It's basically about experiences I had in several different projects, what was the problem there and how we solved it, basically. And it's really basic, so like that you should use Git, that you should use some kind of Git workflow as well, that you use issue trackers, wikis, tests, stuff like that. Like really basic, but in our experience as a company, we had it several times that people are still not using any kind of versioning software or like tests. Most customers really don't have any tests. So that's really basic, but really important as well.
So what's the most important issue you see? You say tests missing, no version control. Are there other ones?
Yeah, it's like a lot of it is with issues and communication in general, how stuff works. So a lot of people are also missing project management, basically. So because a lot of times the systems just grew in the history. They started with one developer, right? And then they grew as a team, and they didn't really know how to handle that. So it's a lot of communication issues because they don't know how to talk to each other, how to delegate stuff as well. So how to create even issues, why create issues. A lot of times you just have to explain why is it useful to have issues, documentation, stuff like that, and tests as well, of course.
And how do you see the evolutions in Java? Do they really help developers to be more productive?
I definitely think so. The Stream API alone, I think it's really helpful to people if they get it, but it's kind of a long way. And also records are something that I think every developer just intuitively uses and likes, because it's such a simple concept, but it really helps with speed as well, right?
Roland Weisleder presented ArchUnit in a talk and explains how you can use it to unit test your architecture. We also discussed if you should understand the bytecode or other internals of the Java virtual machine.
It's a Java library, and you can basically query your Java application, formulate rules about the architecture, and run them as unit tests during the build time, along with your other unit tests.
So architecture, do you mean different services, databases, or really how your application, your code is structured?
It's a good question. So that's how would you define architecture? It's most use them as to check the architecture, also the structure of the application. So, for example, layered architecture, that controller should access service layer and service the persistence layer, and not the other way around. Or if module A should depend on module B and not the other way around, something like that. And that happens on the bytecode.
And that's something which you can test with ArchUnit.
Exactly. And ArchUnit will analyze all the Java classes in your class path and tries to match the rules that you've written in Java code with the actual bytecode and checks if there are violations to the rules or if everything is okay.
Are you a developer within ArchUnit, or are you contributing to that library?
Most of the time, I'm a happy user of ArchUnit since, I guess, 7 years or so. I'm sometimes contributing stuff to ArchUnit, and I've also written a small Java library to integrate ArchUnit and Spring applications, which is the ArchUnit Spring integration, to make it easier to write ArchUnit rules for Spring applications.
So you're contributing to this library. You mentioned bytecode. Do you really dive into the bytecode?
ArchUnit does it. It analyzes what's there in the bytecode to find the dependencies, which method calls which class. So ArchUnit understands the dependencies of the overall application. And you have to write then rules like classes should access other classes or should not access other classes. And ArchUnit does the stuff under the hood.
We have some blog posts, I think, on Foojay about bytecode itself. It's actually a readable text, so you can really dive into it as a developer if you wish to. Do you think as a Java developer you should understand bytecode, or is that only if you go a next level in direction of performance tuning and stuff like that?
I think that's next level. It's the basic step is to understand classes, methods, and that they are there and that you can query them, that you can check if everything is well structured. And for most of the time, that's good enough to know. Yeah.
Yeah, there are different levels within, like you could also try to understand how garbage collectors work, but actually, is that the miracle of Java, that it hides so many complexity for a developer? You can just write Java code and it will most of the time just do whatever you expected it to do?
Yeah, that's the beauty of the Java ecosystem, that you can start writing applications, it will work. And if you want to tweak something, or if you want to get some performance, you have to dive into that topic a little bit more. And there are still options to optimize or to find better solutions. But that's the beauty, that you can start right away with a few lines of code and it will just work.
Mm-hmm. Simon Martinelli is known for his work with JOOQ and Vaadin, but at JCON he gave the talk Return of the Full Stack Developer, in which he explains another framework and return of server-side rendering.
There is a tiny little framework called htmx, and it was a bit overhyped maybe, but people adapted it and said, oh, we could do like server-side rendering again with the help of just a tiny library that adds dynamics to our websites.
What's the main thing I should know about htmx before I start diving in the documentation?
htmx is a JavaScript library that provides tags that you can add to whatever HTML element and make it dynamic. So you can, for example, have a div tag and then add hxget as an attribute. And then if the user clicks on that, a GET request will be executed and it will return some fragment that HTMX then will be replaced in the DOM of your HTML page. That's more or less how it works.
I have to be honest, I love it. I use it for one side project where I had some kind of a touch interface for a machine. And by clicking a menu button, you simply replace the center div with something else. That means that everything you see can be generated by any kind of language in the backend, correct?
Exactly. So it doesn't really matter. So you can use a static HTML page, in fact, and then call like a service written in Spring Boot or in PHP. It absolutely doesn't matter. So it's completely free of any technology.
So that means that you move back a lot of the rendering of how it looks like with diffs and spans back to the server. Is that an outdated technology which comes back, or is this a good technology?
That's a technology that's still around and serves a lot of use cases, maybe. So, to be honest, I prefer component-based web frameworks like Vaadin or even Jakarta Faces, because components are very important if you're building business application and have repeatable tasks to build, like a UI with a grid and a form, and you have kind of higher order components that you want to reuse from project to project. But if you're building quite small applications, or even if you want to use, for example, AI to generate the UI, maybe generating a template and then have fragments to replace dynamically by HTMX is probably a very good idea. And it's very simple to do that, yeah.
Loïc Magnette talks a lot at conferences about Angular and React, so he is the perfect person to give us even more info about current web development techniques. Which one should I use if I start a new Java project?
I would say it depends on a few things. The experience and the willing of the person to learn a new language or not. And based on that, you can already make a choice. Because if you have someone that's love doing backend and love Java and just using Java, you should look at the Java solutions like Vaadin, GSF, Qt, and so on. But if you have someone that's okay with checking what's on the other side with JavaScript frameworks and things like that, there is a lot of things interesting there. Angular is making a big comeback because they made a lot of change to make it more efficient. We are on par with Vue.js. That's one of the most efficient in terms of reactivity and things like that. React is getting a bit behind on that point of view, but there really needs to depend on what do I want to do, what I want to achieve. There is also things like htmx can help you. So really depends on what do I know, what my team does know, and what do I want to achieve. Because if you're just using a backend application for something, you probably don't need all the tips and tricks of a JavaScript framework, for instance.
I love Vaadin a lot because that's pure Java. I'm a Java developer, so that I can build a web interface with Java. That's something I love. From experience in the past, I know that JavaScript libraries tend to change a lot and break a lot between versions. Is that still an issue?
I'm lucky enough to play a lot with Angular, and Angular does a great job, especially since we had Angular 2, and since then, they really try to avoid breakage between versions. Or if they do, it's like we deprecate this version and we leave you for 8, 9 versions between. We delete it and you need to migrate at this point. And they also try to migrate automatically for you. So in that scope there, it's way better than it was. But I cannot talk about any, for instance, if you take React, a lot of people use a lot of other dependency. And then you depend on the community and the will of the community to help you migrate and support if they change something. And that's where you might encounter some pain points.
Because you speak not only about Java, but also about UIs, you come at different conferences, I think also C# and other things.
Yeah.
How can you compare the Java community to the other ones?
I would say that my favorite community from what I've encountered is the Java community, because it's really open, and you can talk about anything, even if it's not Java. We can talk about anything, even if you come to say, okay, I've seen that in C# or something, and I don't know about Java, and every Java developer are like, okay, let's chat, let's learn from each other. Whereas sometimes with some .NET community, they're like, yeah, you've come from Java and try to make fun of you, and I'm like, you can if you want, but I don't see the point. All tools have their purpose, and I can understand that you like that, but I don't think we gain anything by just looking at the other, and that's bad. I think we learn more by looking, how do you do that? How do I do that? And how can we improve from each other?
The next guest is Tanja Obradovic, who works for the Eclipse Foundation. She gives us an update of the status of JakartaEE, and we also talked about the work the Eclipse Foundation is doing in the open source world.
JakartaEE, just a couple of sentences for people who are maybe not familiar with it, is the continuation of JavaEE. So the last version of JavaEE was JavaEE 8, and then Oracle has contributed the whole body of work to the Eclipse Foundation, and the community voted that the technology will continue with the JakartaEE name. So we have all the specifications and related implementations at the JakartaEE. Probably the most famous one is Glassfish. And we're now actually developing JakartaEE. We're just about to release JakartaEE 11. And we have already started the work on JakartaEE 12. So what has happened in last few years since it came to Eclipse Foundation? So not only that we had quite a few releases, some would say probably more releases than last few years while it was with Oracle, but we managed to do quite a few innovations. So one thing that we had to deal with is to change the JAVAX namespace to Jakarta namespace. I'm sure people who are dealing with that are familiar. But we also introduced a new profile. So Jakarta core profile. It came about in version 10. There are a couple of new specifications in JakartaEE 11. There is Jakarta data. There are a lot of discussions about other new specifications that are going to come into possibly come into version 12. But also we're introducing, maybe it's worth noted that we're introducing independent release of profiles. So it's not that you have to wait for the whole platform in order to use it. There are implementations that are now specific to the core profile or to the web profile, and then the platform. So yes, the core profile 11 was released in December. The web profile was 11 was released in March, and we're just about in next few weeks. We're expecting the release of the platform, but we're super excited to have the 12 also underway. So go visit jakarta.ee and find out more.
Okay. You also give talks, not at this conference, but what is the main topic you talk about at conferences?
Yeah, I talk about open source at the Eclipse Foundation, and I often use a topic of JakartaEE and how open source at the Eclipse Foundation and vendor-neutral approach of the specification has flourished, and how that actually enables community to participate and evolve and innovate in this technology.
Mm-hmm. Eclipse, we know it from the editor, the IDE, now also Jakarta. What other Java-related things are within that foundation?
Okay, that's a huge topic. Yeah. There are tons of Java-related projects at the Eclipse Foundation, and we're getting submissions and proposals on a regular basis. One that I want to call out is the Adoptium working group, and Tamarin, the distribution, JVM distribution. You should all Java developers have a look into it and see the advantages of that approach. But I would say there are many other smaller projects that could be Java related, but not only Java related. So there is a huge space now that Eclipse Foundation is European-based open source foundation, the largest in Europe. There are open regulatory compliance working group ensuring the open source regulations are not putting restrictions on the open source community and open source development approach. There are software defined vehicle working group, extremely interesting and popular. And there are many others, we call them industry collaborations, where organizations can get together and work on the technology they're interested in and make sure there are innovations and share of the information and share of the knowledge, of course.
Imagine I'm involved in an open source project. It's managed by a small group of people, volunteers. What could be the benefit of joining the Eclipse Foundation with a project?
So there are many benefits. I'm sure, first of all, I would like to say that there are various ways of doing an open source project. I can start my own GitHub project and then be clueless about the governance or IP or licensing or anything like that. Then there could be one vendor company doing open source projects. A great example could be Red Hat, right? And then there are foundations. So foundations are there typically to make sure that IP and licensings are taken care of, something developers don't like to deal with. Then there is infrastructure that is provided by a foundation like Eclipse Foundation. We like to make sure that anything that is proven by code that is worthy is something that our slogan is code first, so it needs to be proven that it's worthy of gathering companies and individuals and making sure that it's a business also friendly, potentially business friendly product. There are marketing services that we provide, of course, process and governance structure. So one of the things Eclipse Foundation is known for is for its Eclipse development process. So that's for the implementation projects, but we also have the process for developing specifications. So Eclipse specification development process and then specialization of that. For example, in Jakarta, that is a body of specifications, is Jakarta specifications development process. So all of these things are something that Eclipse Foundation is. I want to mention actually vendor neutrality. That's one of the big things that Eclipse Foundation is focusing on. So making sure that if there are multiple vendors, organizations developing a process, developing a project, that the project is not dominated by one company. JakartaEE is, again, an example of that.
Usman Ahmad works at Grafana Labs and is the perfect person to learn us more about the tool to visualize any kind of data in an easy way in beautiful dashboards. But for most people, including me, Grafana comes in a package with Prometheus. But is that still true?
That's a very good question, actually, for starters. Grafana has a very good reputation in the market, but if you ask someone on the street or like any tech guy, the first thing comes like Grafana, that means Prometheus. But it has changed. Grafana now supports a lot of data sources. We have a whole catalog of plugins where you can define data sources, panels, and even apps from our community as well. And for example, you can use Grafana to visualize all your GitHub metrics, or you can use Grafana to visualize something like MySQL. And this is without any usage of Prometheus. So it has changed a lot. And for viewers who are might be more interested, they can check grafana.com/plugins, and they can see a whole catalog of Grafana.
Okay. What tools would you highlight or systems to integrate with Java applications?
Yes. So nowadays, the industry is very rapidly growing, and especially if someone knows about the CNCF landscape, there was a very big investment on a project called OpenTelemetry. But before OpenTelemetry, we should go one step back. It was the default standard is to use Prometheus to capture all the metrics. OpenTelemetry now is the most contributed project of the CNCF landscape so far. But what highlight is that you can actually use both. You can go OpenTelemetry or you can go Prometheus, because we have to know the fact that every industry or every company has different set of standards or workflows. So if someone may want to use Prometheus, yes, you can use that. And when we are talking just Prometheus, then you need something to visualize. So normally you can use something like an open source stack of Grafana to work as a data source with Prometheus, and you can visualize everything. However, metrics are just not enough, because it can tell you like where the CPU goes high or down. So you probably need more than just one thing. So that means you need logs, you need also maybe tracing, and somewhere you might need more advanced troubleshooting. And for that, you can use profiling. So this is what we call LGTMP stack. So logs, metrics, traces, and profiling. And this is a completely composable open source stack, and you can use this with Grafana.
And if you're using Spring, like probably a big part of the Java visitors here, Spring has some OpenTelemetry and Prometheus endpoints by default that you can very easily enable, right?
Yes, actually, I got a question in my talk that like using Spring, and they have like multiple microservices. So, for example, in the world of Java, there's a known tool as Micrometer, and it is compatible with Prometheus, right? So you can use Prometheus, which works with the Spring Boot services, and you can visualize all these metrics in Grafana. One addition is that we recently launched Grafana 12, and we added some cool features. So one of the feature, or which was also highlight of my talk, is that you have a lot of things. Like when we talk about logs, metrics, traces, basically we are talking about the 3 pillars of observability, and also the 4th pillar is the profiling. That means that you have to learn how to write PromQL, how to write LogQL for logs. And maybe you can't memorize each and everything. So what we did is that we created an app which is called Drill Down app. And with that, you can get all these metrics on the fly. Only you need to configure is the endpoint. So you don't need to memorize each query. You just need to see like, okay, select this result, and you will get it directly in Grafana. Grafana has one cool plugin, because imagine that you have your Spring Boot service and there is an API endpoint, which is important, but somehow it is not defined in your Prometheus tool. So, but you have the access to get some sort of metrics using curl command. But curl, again, we're talking about like very low level on the shell. Grafana has a plugin called Infinity Data Source plugin. What it does is that you can define like an API endpoint inside the Infinity plugin, inside actually Grafana editor, and say like, this is my endpoint and I just want to get the results of GET requests. That will be visible inside Grafana as a visualization table panel or something. and then you can modify it and create like a fancy graph. So this is, I think, most advanced and cool feature is to use these sort of plugins.
And all these plugins, Grafana, is that all open source and free, or is there some kind of licensing model?
So Grafana has 3 licensing models. So the first one is the open source one. You can use this whole stack and even like Infinity Data Source plugin as open source. This is completely open source. You don't need to even pay a penny for it. Then we have the other model is the enterprise one. If you don't want to manage your Grafana instance by yourself, then we can do that. And definitely last but not least is the cloud. For the cloud, you basically say that we manage it. And obviously in cloud, you get more advanced features which are cloud related. For example, if you are running Kubernetes applications, so there are some built-in integrated tools in the Grafana cloud that helps to monitor your Kubernetes server more better. So yeah, but I would say that, which I also prefer, that start with the Grafana open source, feel how it works, and maybe if you need more, then go beyond.
François Martin brought a small 3D printed toolbox to the conference, which he used for his talk about tools. We also talked about Toxyproxy and chaos testing.
My talk is called From Bugs to Brilliance, Testing Toolbox in Action. And, I thought, since it's called, Testing Toolbox, I thought I'd bring a real toolbox. So, of course, I was just able to travel with hand luggage. So my real toolbox didn't fit into the luggage. So I thought I'd print a little, toolbox here and use it to bring it with me. And I will also be giving one away at my talk. So, so someone can take this home as a souvenir kind of. And so people can come with their empty toolbox, just like in my case, and they can fill it up with tools. Just, they need to make sure that it doesn't get too heavy so they can't take it home with them, of course, right? So.
Yeah. And which tools are important? What's the main things you talk about during the session?
So the interesting thing about this session is that I have a lot of different tools that I'm showcasing and a lot of demos, but it's kind of interactive. So I'm asking the audience basically what they would like to see in terms of what tools they deem to be important or what they think is important. I feel like it also depends on what tools you already know and you don't know. But of course, I think there are many good basics that a lot of people don't know already, like especially in the Java ecosystem, there is like a search, for example, that, is something that a lot of people know, but there are still lots of people that don't know about it. It makes it a lot easier to write tests that are very maintainable and don't have too much logic. So, they don't contain logic that could break or have the risk that you introduce other bugs, into the test code, which we also obviously don't want. But then there are other tools, like, for example, I have an example with test containers and with Toxyproxy, which is kind of like a tool to simulate what happens, for example, when your connection to the database breaks. Like I had a case at a customer, actually, where we were having a connection to a database, and we never tested the case what happens when the database is down for some reason. And we noticed, the application was actually crashing when the database was down. And this brought me to the point where I thought there should be a way to test this, because we need to make sure that this doesn't happen again. And so for me, every time I find a bug or when we have an issue, I want to reproduce it first. So to do it kind of like TDD style. And I was looking for ways to do this. And then I came up with this solution. And I think this is a brilliant tool. It's also open source. Toxyproxy was developed by Shopify, probably to test their resilience. And it's so cool what it can do, and you would probably be surprised when you try it on your own applications to see what kind of issues come up that you didn't expect. So
I know that, for instance, Netflix has this kind of monkeys which shut off the services in production. Yeah. Would you go so far in testing, replacing Toxyproxy with doing that in production?
Actually wouldn't replace it. I think both are complementary, in my opinion. So the thing you mentioned is chaos testing, where, for example, you turn off a service in production and then see what happens. And I think you need to have both in a way. So you should have the Toxyproxy, for example, to get instant feedback. So that, for example, when you do a pull request and you make a change to the code that causes, for example, now the application to crash, you don't have to wait until a chaos test catches this, because still the chaos test you usually do in production or production-like environments. And it takes quite a long time from when your code, is in development until you're there. And from that point on, when you notice, oh, suddenly the database is crashing, it will take you quite a long time to be able to figure out which of those changes that we have made, unless you deploy like every day, right? But usually most of us don't. It will take you quite a while until you find the exact change that caused this issue. And by doing this with Toxyproxy, you can prevent this. But with the chaos testing, I find it especially useful to also see like how well is your staff trained, for example. I mean, to see if, for example, service goes down, do they get notified of that? And how do they react in those situations? I think it's also a good training opportunity for them in this way. And I think that is another benefit, which is why I wouldn't just do one or the other. I think both is the perfect mix that you have to do.
Is chaos testing something reserved for big companies? I can imagine if you have a small team and you're just trying to get things implemented, dealing with chaos is not something you would like to do. But is it possible as a small team to do that kind of approach?
I definitely think so. So I would say every team, at least as long as you have an application that you deploy to production, and if you are the team that maintains it, so especially if you are in the DevOps team in a small client or like small application with a small team, this could still be something that could be worth your time. I think it really depends. I mean, if your application just started out and you don't have that many customers, it's probably not as crucial. But at some point, you get to the point where you get a lot of attention and where your application starts to become like, mission critical. I would say when you get to a point where you could say that you don't want to have downtime in a way, that's the point where you should start, let's say the latest with chaos testing. Because if you're at the point where you say like, oh, it's fine if our application is down for 2 or 3 hours or like 10, 15 minutes, then probably you won't really need to do chaos testing at that point. But once you get to the point where you say like, oh, even just having a downtime more than 5 minutes, would be bad for us, I think that would be a point where I would introduce it, certainly.
That's it. Now you got all the JCON interviews. Again, it was amazing to talk with all these guests about their experience with Java and software development. And I hope you learned as much as I did from all these interviews. Thanks for listening. Please subscribe to the Foojay Podcast in your app or on YouTube. Keep an eye on foojay.io for future articles and podcasts about development and everything related to the Java world. See you!
Give me a foo, give me a J, give me the friends of OpenJDK.